Good afternoon, everyone. For our first lecture, we will discuss about quotient topology, a very important concept or construction um, for our course, algebraic topology. By the way, in this course, I am assuming basic familiarity with the notions of topology, those things that you study in Math 242. But don't worry, I won't leave you in the dark. Yung mga concepts that I assume you are familiar with, I will mention them. So if you are not familiar with them, you can read about them during your free time. Um, Also, ang setup natin, so let me also take this opportunity to tell you our setup for this course. So I will be sending you copies of my lecture notes. So hopefully masend ko sila sa inyo ahead of time. Pero sometimes they will be delayed. Pero okay lang kasi I will give you enough time to read them. Tapos those lecture notes, they will be accompanied by videos. So precisely what I'm doing right now. Pero dito sa videos na to, hindi ko mako-cover lahat ng details. I will only mention things that in my opinion are crucial. Yung mga obvious remarks, obvious exercises, proofs that are straightforward, I will leave them to you. Chances are you can read them with ease. Okay, so on with our first lecture, quotient topology. So what is it? First, let's start with a topological space X with topology tau, tilde, an equivalence relation on X. Tapos let's denote by this familiar symbol. I mean, for sure, nakita nyo na to before. We will denote by this the set of all equivalence classes of X modulo tilde. And associated to this setup, we have this map, P, the map from X to X mod tilde, the map that sends X to its equivalence class. And obviously, this map is surjective. This is what we call the canonical surjection. Again, let's recall our setup. In this case, X is a topological space. That means it comes with a topology. But this is just a set. So at this point, it is just a set. So we might ask ourselves, so can we put a topology on X mod tilde so that P is continuous? In fact, the answer is yes. And we can do so in many ways. Pero, although there are many choices for the topology on X mod tilde, which will make P continuous, there is a largest one. And that largest one, by default, will be unique. So what do I mean by largest one? So that means that any topology which on X mod tilde which will make P continuous will be contained in that topology I am referring to. So that largest topology. So that largest topology will be what we will regard as the quotient topology on X mod tilde. And now I will outline to you how to construct it. Okay, so naalala niyo pa ba from Math 242 how we specify topologies? I mean, the most straightforward way would be to specify the open sets of the topology. Tama? We can also go around it by declaring certain subsets, and then we generate the topology of those subsets. Okay. So let curly b be the set of all subsets of x mod tilde such that the preimage of u, again, to remind you, P is a map from X to the set of equivalence classes. So this is a subset of X, tama? And we are collecting in B all those subsets U such that this preimage is open in X. Or in other words, an element of tau. Tau is the topology on X, if you remember. Tapos, denote by tau sub q the topology on x mod tilde generated by curly b. So again, these are familiar constructions from Math 242. Okay, so this topology is what we will call the quotient topology on x mod tilde. Okay, so few remarks are as follows. So first, yung subset u of x mod tilde, this is open. Of course, by open, I mean open in the quotient topology. If and only if yung union ng mga equivalence classes that are in U. So again, to remind you, si U ay ano ha, being a subset of X mod tilde, U is a set containing some equivalence classes. So mga elements ito equivalence classes. So if those elements are themselves sets. Tama? Equivalence classes are sets. So if you take the union of those sets, if you take the union of elements of U, them being sets themselves, if you take the union, this will be a subset of X. Tama? And this remark tells us that U is open if and only if this subset of X is open in X. Ano ba? Tapos, I want you to verify that the quotient topology on x mod tilde is the largest. It's the largest topology on x mod tilde, which makes the canonical projection P continuous. Again, anong ang ibig sabihin natin ng largest in this case? Largest means that any topology that you can put on x mod tilde for which P is continuous must be contained in this quotient topology. Maliwanag? Okay. So let's give. Okay, so at this point very abstract yung construction of quotient topologies. But as I said, it is crucial for our course. I will give you several constructions which will at least make this construction understandable or familiar. Okay, so let's start with examples. So number 1, let's consider the unit square. So this is the set of ordered pairs such that yung x and y they range from 0 to 1. So parang ano no, so kung ito yung 0, ito yung unit square. So this square. Tapos let's define an equivalence relation na marami akong didiscuss na equivalence relation from here on. So let me distinguish them all. So dito let me define the equivalence relation tilde sub t. So define tilde sub t on x as follows. So how do we define an equivalence relation on a set? We have many ways to do that, pero one particular way would be to declare what elements of x are, by x I mean, so in this case we are taking x as our unit square. So to define an equivalence relation on x, it is enough to specify what points are equivalent. Maliwanag? And that will completely specify the equivalence relation. Maliwanag ba? So dito, I will declare 0y to be equivalent to 1y. And x0 is declared to be equivalent to x1. So for all x and y between 0 and 1. Tapos, so ano itong mga points na to? 0 si x, and y can vary. Y can vary from 0 to 1. So ito yung mga points na yun, yung mga points dito sa line segment na to, end to end. Ito namang 1y, they are points on this line segment. Tama? So I am declaring that this point, whatever this y is, so 0y, I'm declaring that to be equivalent to this point. 1 with the same y. Pero 1 lang yung first coordinate. So ito, para magkatapat sila, I declared them to be equivalent. Ganon din dito, because of this equivalence relation, ganon din dito. So pag meron akong point dito, I declared that to be equivalent to the point above, pero directly above. Okay. So pero, sabi ko, we need to specify what points are equivalent. Hindi ko pa mini-mention yung mga points strictly inside the unit square, tama? Those points strictly inside the unit square, they will be alone in their equivalence class. Maliwanag? So, for instance, this point, yung equivalence class ng point na to only contains this point. Maliwanag? While the equivalence class of this point contains 2 points, this and this. Same dito. The equivalence class of this point contains this and this. So for this equivalence relation, yung mga equivalence classes, they are either singleton or doubleton. Maliwanag? Pero madalas kong gagawin tong construction na to. So I will define an equivalence relation telling you what points are equivalent. Yung mga hindi ko ma-mention na points, they are regarded alone in their equivalence class. Maliwanag? Para hindi na tayo paulit-ulit ha. So, kagaya nito, so pag dineclare ko na ganito, you should assume that those points that are not mentioned, they are alone in their equivalence class. Maliwanag? Okay, so now the question is, what then is I squared modulo this? So what is I squared modulo this? Okay, so let me do it here. So actually, siguro at this point alam nyo na, no? So this will be the torus. So let's see. So let's do it step by step. So pag in-identify ko yung points dito, 2 points here, basically what I'm doing is I am sort of attaching this part to this part. Kasi originally these 2 points, now they will become 1. So parang nangyari, this line segment will be the same as this line segment. So doing that, we will end up with a cylinder. So ito yung line segment na in-identify natin. Ito tsaka ito. Now they are one. Now they are the same line segment. Tapos that's not all. So itong line segment na to, kailangan din nating i-identify with this. Tama? So this boundary will be sort of attached to this boundary, and doing so will give us a cylinder. Sorry, a torus rather. Okay. Okay, another example too. So for this example, we consider the same x, yung I squared. Tapos, here, I will declare 0, 1 to be related to 1y. Again, so this will be a different equivalence relation, so let me call this tilde sub k. So define tilde sub k on x as follows. So yun, 0y is equivalent to 1y, while x0 is related, or rather equivalent, to 1 minus x, 1. Again, those points that are not mentioned, they are solitary in their equivalence class. Maliwanag? So now the question is, so what is I squared modulo tilde sub k? So ganito, again, I squared is the unit square. Tapos, we will identify this line segment with this line segment. Tapos tapatan, yung point na to will be identified to this point, yung katapat. Pero iba yung nangyayari sa x. So dito, itong line segment na to will be identified to this line segment, pero in a different manner. So itong x na to, it will be identified to the point 1 minus x. So nasan yung 1 minus x? So if this is x, 1 minus x is this. So this length is x. So ito si 1 minus x. Maliwanag? So itong point na to, ma-identify with this. Tapos as we progress in this direction, the points here progress in that direction. Maliwanag? So meron tayong mnemonic device to capture that. So let me recast this again in a much clearer drawing. I will put arrows dun sa mga line segments that will be identified. And I'm putting an arrow this way. Ibig sabihin, this line segment will be identified in the same direction. So this and this, they will be identified as is. While for the bottom and the top segments, I will put these arrows. So ibig sabihin, since the arrows are in reverse, ibig sabihin, I need to flip one of the arrows first, and then bago ko siya ma-identify with the other one. It doesn't matter kung i-flip nyo, it will give the same result. So if I flip this first and then identify with this, that's the same as flipping this and then identifying it with that. Maliwanag? Okay, so what will we get if we again, in the past example, when we identify the opposite edges of this square, we got the torus. Dito kaya, ano makukuha natin? So again, let's do it step by step, no? So identifying these two line segments give us a cylinder. Hindi pa ito yung final space, hindi pa ito yung I squared modulo tilde kasi few points, yung some points pa lang yung nako-collapse natin into one. Hindi pa lahat ng equivalent points. Maliwanag. In particular, points here are also equivalent to points here. Pero dito, in this drawing, you can still see na they stand as different points. Maliwanag. So this is not yet this space. Maliwanag. This is just an intermediate space. So, pero tingnan natin so kapag in-identify ko to, paano oriented tong boundary circle na to? It will be oriented this way. Tama? While itong nasa baba will be oriented differently. Tama? So kung observer kayo from above, itong circle na to ay oriented counterclockwise while this one is clockwise. Maliwanag? So now I need to identify them. So let me bend this space a bit in a U-shaped manner para mas madali natin execute. So again, this is topology, so we can perform those bendings. So if we do that, ito. Again, this is oriented this way. Ito yung ito yung line segment na to, naging ganito. Tama? Kaya lang ito, paano oriented tong boundary na to? Inangat natin siya, 'di ba? Nung inangat natin siya, this is before it was oriented it was oriented clockwise. Now it will be counterclockwise. Can you verify that? So if so bending this in a U-shaped manner basically flips this circle. So nung flip nyo siya, the orientation was also flipped. Maliwanag. So now they are both what do you call it? Counterclockwise. Maliwanag? Ngayon, kung maalala nyo, for the torus, basically yung ginawa natin sa torus, in-stretch pa natin to further and then flip ulit natin. Tama? If we do that, if we stretch this further, tas flip natin, this boundary circle will now be oriented clockwise. Tama ba? So, hindi siya magmamatch sa circle to kasi this is oriented counterclockwise. So, kung isa-stretch pa natin to further, it will be counterclockwise, hindi natin siya makakonect doon. So, again, the resulting space will not be the torus. Maliwanag ba? So, we don't expect the torus to be this. So, ngayon, actually, these two circles are already the same orientation. So, ang pwede natin gawin, ganito. Ang pwede kong gawin, i-move ko to closer and closer until mag-coincide sila with that circle. So let me draw. Let me draw that. So basically ito, pinush natin inward. Tapos you might ask yourselves, okay, merong self-intersection. Ito mga points na to, do we mean, so these points are certain points here, tama? And then they coincide in this drawing. nag-coincide lang sila but they are different points. So, ibig sabihin, itong point na to na nandito sa part na to, iba sa point na nandito sa portion na to. Nagkataon lang na sa pagkakadraw, nag-coincide sila. Maliwanag? I will give a concrete example of that later. Pero, we will have that problem kasi this is a two-dimensional rendition of something that is happening in so actually already here this is a three-dimensional sorry. So we are doing this in 3 dimensions, tama? So to execute that properly, actually we need higher dimensions to perform this. You don't have to you don't have to know about those. Pero importante dito, these are just drawings. They represent actual sets. Maliwanag? And as sets, we are not identifying interior points to some interior points. Remember, they are left to be alone in their equivalence class. Maliwanag ba? So dito, fictitious to self-intersection na to. Meron lang self-intersection sa pagkakadraw, but mathematically speaking, walang self-intersection. Maliwanag? So again, the boundary circles are now oriented the same way, counterclockwise. And all we have to do is sort of expand, or rather, whatever we do, expand the inner boundary so that it will coincide with the outer boundary, or we shrink the outer boundary to coincide with the inner boundary. Maliwanag? And doing so, we will have the familiar Klein-Bottom. So let me draw it here. So this is the Klein-Bottom. Okay. For our third example, so again, x is I squared. And now let's define tilde sub p on x as follows. So in this case, 0y will be equivalent to 1 minus y. And x0 will be related to 1 minus x1. Okay. Again, interior points are left as so ito in their equivalence class. So what will we get if we do this? So again, we start with the unit square. Tapos we identify this edge with this edge, pero in an opposite orientation. Pas ganun din dito, we identify this edge with this edge but in an opposite orientation. Maliwanag? So again, let's do it step by step. We will have intermediate spaces doing so. So dito, if I identify this with this, pero we have to flip this first. We will get what we call the Mobius strip. So let me draw that. So ito yung ano, no? Yan. Or let me draw it better. So we'll have this so ito yung edge na flip natin. So ngayon so if this edge is going this direction, it will be followed by this edge going this direction. Kung ito yung edge na yon, this one, this will be oriented this way up to this point. Tapos pagdating natin dito, we will trace out this edge again, pero this time it is on this side. So pagdating natin sa dulo, we move in this direction here, but now it is oriented this way. So going around this. Yan. So ngayon, ang task natin ay to identify this boundary. Yan, itong portion na to. Kailangan natin to identify with this portion of the boundary, pero in the prescribed direction. So, mukhang mahirap imagine, no? Pero, what we will get here is the projective plane. Medyo mahaba na yung video, so I will outline why this is the projective plane in the next video. So for now, I will stop with this example.